Solar panels are remarkable devices. They transform sunlight directly into electricity. This is possible because of something called the photovoltaic effect. It's a bit complicated, but basically, light knocks electrons loose in certain materials, creating an electric current. Solar panels are becoming increasingly important as we look for clean and sustainable energy sources. They offer a fantastic way to reduce our reliance on fossil fuels. Fossil fuels contribute to pollution and climate change. Solar panels, on the other hand, provide a much cleaner alternative. They have the potential to revolutionize the way we power our world. The journey of a solar panel begins with simple raw materials. The most important of these is silicon. Silicon is a semiconductor, meaning it can conduct electricity under certain conditions. Luckily, silicon is incredibly abundant on Earth. It's found in sand, which is essentially pulverized rocks. Other materials are also crucial in the manufacturing process. These include metals like silver and aluminum. These metals are used for the electrical contacts that help extract the electricity generated by the solar cells. Glass, plastic, and polymers are also used in the construction of the panels. These materials protect the delicate solar cells from the elements. The first step in making a solar panel is to transform raw silicon into a usable form. This starts with extracting silicon from sand. The extracted silicon is then purified to a very high degree. It has to be incredibly pure to work effectively in solar cells. This purified silicon is then melted down at extremely high temperatures. Think of a very, very hot furnace. Into this molten silicon, a single silicon crystal is dipped. As the crystal is slowly pulled up, it draws the molten silicon with it. This forms a large cylindrical ingot of solid silicon. These ingots are then sliced into thin wafers, much like how you would slice a loaf of bread. These wafers form the base for individual solar cells. Section 4: Solar Cell Fabrication, transforming silicon into electricity generators. The silicon wafers, now thin and shiny, are ready to be transformed into solar cells. This begins with a process called doping. Essentially, impurities are intentionally added to the silicon. These impurities alter the electrical properties of the silicon, making it more conductive. Next, a thin layer of anti-reflective coating is applied to the wafer. This coating helps to trap more sunlight within the cell, increasing its efficiency. Metal contacts are then added to the top and bottom of the cell. These contacts act like gates, allowing the generated electricity to flow out and be used. Section 5: Panel Assembly. Connecting the dots of solar energy. With individual solar cells ready, the next step is to assemble them into a solar panel. This involves connecting numerous cells together in series and parallel circuits. These connections are carefully soldered to ensure good electrical conductivity. The entire assembly is then laminated between layers of protective materials. These materials include glass, plastic, and a backing sheet. These layers protect the solar cells from the elements and provide structural support. This entire package is then framed, typically with aluminum, to give it rigidity and allow for easy installation. The frame also provides a way to ground the panel, ensuring electrical safety. Section 6: Quality Control and Testing, ensuring efficiency and durability. Before a solar panel is deemed ready for use, it undergoes rigorous quality control checks. These checks ensure that each panel meets the required standards for efficiency and durability. The panels are tested under simulated sunlight conditions to measure their power output. They are also subjected to extreme temperatures, humidity, and mechanical stress to test their resilience. Only panels that pass these stringent tests are packaged and shipped for installation. Section 7: Conclusion: Solar panels, a bright future for renewable energy. From humble grains of sand to sleek, electricity-generating panels, the journey of a solar panel is a testament to human ingenuity. The process is intricate, involving sophisticated engineering and manufacturing techniques. Yet, the underlying principle remains simple: harnessing the awesome power of the sun to meet our energy needs. As we face the challenges of climate change and resource depletion, solar panels offer a beacon of hope. They represent a clean, sustainable energy solution, paving the way for a brighter and more sustainable future.